This time, let's talk about Avogadro's law. Avogadro's law was first introduced by Amadeo Avogadro. When we talk about Avogadro's law, it is the relationship between the amount of gas and the volume of a certain object, where the temperature and the pressure held constant. When we say constant temperature and pressure, there is no change of a temperature and pressure. Instead, our variables here are the amount of gas and the volume only. One of the best example of this is an inflated balloon. Now, if we are going to untie the balloon and put some air in there, the balloon will probably get bigger at its size. And if we release some air out, the balloon would probably get smaller. So what does this mean? This means that there is a direct relationship between the amount of gas and the volume. To make it easier to understand, as the amount of gas increases, the volume increases, and as the amount of gas decreases, the volume decreases. So they are directly proportional. Here's the graph that best represents Avogadro's law. So let's take a look here. As we increase the amount of gas, the volume increases. So they are directly proportional. So keep that in mind, that as we increase the amount of gas, the volume increases. Or as we make the gas out of it, the volume decreases. So, Avogadro's law is used a lot for math problems. And as we talk about math problems using Avogadro's law, the form of the law we used is N1 over V1 is equals to N2 over V2, where N1 is the initial amount of gas over the initial volume is equals to the amount of gas change over the volume change after we done something. So, let's work through this Avogadro's law by looking at this math problem. In a sample of gas, 50.0 grams of oxygen gas take up 48 liters of volume. Keeping the pressure constant, the amount of gas is changed until the volume is 79 liters. How many moles of gas are now in the container? In this case, we must find the given in the problem how many amount of gas and volume before and after we done something. So, the initial amount of gas is 50.0 grams, and the initial volume is 48 liters. And after we done something, the V2 is equals to 79 liters, and into here is missing. Now keep that in mind, that N here will always be in moles. Now the problem is our initial amount of gas is in grams. To convert grams into moles, here how it is done. The amount or mass of the oxygen is equals to 2 times 16 equals 32.0 grams over 1 mole, because each oxygen weighs 16 and we have 2 oxygen here, so we have 32.0 grams over 1 mole. To convert 50 grams into moles, follow these steps. So we have 50.0 grams times, we are going to flip this to cancel out the grams. So times 1 mole over 32.0 grams equals, cancel out grams, equals 1.6 moles. So we're going to replace our initial amount of gas here with this. So we're going to cancel out this and replace it with 1.6 moles. So we have our initial amount of gas in moles, our V1 and V2 in liters. So we're good to go. Now to find N2, we have this equation. We arrive this equation from this by multiplying V2 to each side. So we are going to cancel out V2 here, and here's the equation, but I already make it simple. So N2 is equals to V2 times N1 over V1. So to solve the problem, N2 is equals to V2. Our V2 here is 79 liters times N1. Our N1 is 1.6 moles all over V1. Our V1 here is 48 liters. Now N2 is equals to 79 liters times 1.6 moles is equals to 126.4 liters per mole all over 48 liters will equal to, cancel out liters, it will equal to 2.6 moles. So our V2 here, N2 is 2.6 moles. So N2 here is 2.6 moles. Okay, I hope you understand the Avogadro's law, and thank you for watching.